All right, so let's keep going. I believe we have 2 slides left. Okay, so recalling and putting everything together, when there is existing two, when there exist two separate logs, we combine them into one with multiplication, if it's addition. So when there are two logs that are subtracting, we combine them together for division. And then last but not least, so like we saw, we move that in front as a coefficient. And vice versa. These are interchangeable both ways, okay? So not only will you try to combine them into one, but sometimes you will expand it. So if you go this way, you're expanding the logarithm. This goes with your homework. But if you're going this way, you're combining into just single logs. So what we're going to do is we're going to look at our next question that says, write an equivalent expression for log of x squared divided by log of y. Divided by y. So I have one log. That's first and foremost. Let's identify that. And if I want to write an equivalent expression, that means something that's equal to what I see. Let's say that I want to expand this. Okay. First of all, I would write this as log of x squared minus the log. Notice this log just appeared because I'm going from this one, right here into 2. Okay. So those are equivalent right there. And then now I can use this third rule to even pull this 2 out in front. So this is equivalent, but I could have also written 2 times the log of x minus the log of y. So this, and this, they're all equivalent. Chances are, though, you're going to be asked to go to this expanded form. Okay, so combining all those laws together would get you there. So now, if log of n is x and log of m is y, write in terms of x and y an equivalent expression for this. Okay, so first of all, the way we could start this would be the log of this product of m times n is all square rooted. And inside is where this log, all of that is inside of the log's argument. Okay, so already you can see, I'm going to move this 1/2 out in front. Okay, because exponents happen before multiplication, right? In PEMDAS, we're going to be looking at the exponent first. So we would move this to 1/2 of log of m times n. I'm just going to write mn, just know that there's multiplication there. And then now from here, this is very important. These are parentheses mistakes. Okay, this will expand from the rule 1 up here. This will expand to say log of m is adding with log of n. And now this 1/2 that was out in front, it was multiplied by this entire thing. So it would be distributed. So you could write it like this, or you could write it with the 1/2 already distributed to both of them. But understand, if you write it just with one of the 1/2s with no parentheses, it's going to be wrong. It needs parentheses because this parentheses is showing that that's what happened with the orange part. Okay, so you still have that constant distribution of that 1/2. So let me go ahead and kind of simplify it all the way out with no parentheses. Remember, simplify usually means without parentheses. This would be your final answer. Now, number 3 says if log of 2 is m, okay, log of 6 is n, then log of 48 equals what? Okay, so there's quite a bit going on right here. All right. So first of all, let's recognize like what relationships exist between the two. If I'm looking for log of 48, this is the same as like log of 8 times 6. And I just chose 2 factors that multiplied to give me 48. But the reason why I chose 6 in particular is because I have a 6 over here. Okay, so if I use my laws, and I'm going to expand this, I would get log of 8 plus log of 6. And now I know log of 6 is right over here as n. Log of 6 equals n. Okay, so I already know that there's an n right here. Now, I don't have log of 8. I have log of 2. So I can then further expand this one to say like log of 4 times 2. Okay, so let me go ahead and write that here. I'll just change the 8 to 4 times 2, which this right here is going to become log of 4 plus, because there's multiplication happening right there, log of 2. Well, get this. My log of 2 just appeared. Right here, it just appeared, and that's what I needed. This is m. Okay, and then so I have m plus n, and then this log of 4. Okay, so this log of 4 you could say is 2 times 2. So I'm going to go ahead and change that one in here. And then this is going to be log of 2 plus log of 2. And the reason why I'm adding is because there's multiplication inside here. So I'm expanding it. And log of 2 we know is just m. So I have m plus m plus m plus n. So C would be the answer. 3 m's plus n. All right, so let's keep going. We're almost done. So let me make some room here. And number 4 says expand the logarithm. Well, let's look at the argument. It's multiplication, so expanding it would be log of a plus log of b. Pretty easy. Next one. When there aren't any parentheses written, guys, anything multiplied that happens after this log, anything multiplied together, you'll see this in calculus a lot. It's very big. A lot of people forget it. Please remember it. The log of any product that follows, where the product ends, that's where the argument ends. So if it was like log of, let's say, 2x plus 1, well, then the way you would interpret that, if there aren't any parentheses written, would be this. The parentheses would go with the 2x because all of this is glued together with multiplication. This plus 1 would not be interpreted that way. If they wanted that, then they would have to specifically write that. Okay? So when you have to write parentheses and when you don't have to, you need to understand what will be interpreted. Okay? So here, it'll be log, let's handle that multiplication, log of a squared plus log of c. Again, we're expanding this. We saw multiplication existed there, so we made addition here. The next step we're going to see is this power. So rule 3, right? We're going to move it out in front. So we could say it's going to be 2 times the log of a plus the log of c. And this would be our expanded form. Notice how we're not only breaking it apart, but we're trying to have no powers inside the argument. Those powers are 1, like a to the 1 and c to the 1. All right, next one. We have log of a minus log of b. That's pretty straightforward. Okay. Next one we have division. Okay, so we're going to break it up into subtraction. So we have c cubed minus log of b. And then now we see this, the second step of expanding. We're going to move this out in front. So we'll say 3 times log of c, which now you see is the power of 1, and log of b. And there's multiplication that exists here. Now, notice this multiplication is only to this log of c. It does not distribute over here because there aren't any parentheses going on here. Okay, so it's only attached to that log of c. That's different than what you saw up here. That would expand to both of them. Notice the difference. Again, this is all with practice and recognition of these little nuances between problems. Okay, here we go. So I can break it up with the division as I've been doing first. Or if you want to rewrite this, you could. You could rewrite it as a to the 1/2 over c squared and then log. But either way, you're going to get to the same place because you're going to break it up into 2, a to the 1/2, and then subtracting log of c squared. And then the second step is move this out in front as a coefficient. So you have 1/2 times the log of a minus 2 times the log of c. Notice that we did that in this one as well, as bringing it in front of its term. It didn't come all the way over here. It just goes out in front of the term that it's the argument for. Okay? So this would be the most simplified answer. Okay, so let's go over here up top. They get a little bit more involved here and there, but nonetheless, the approach is the same. I'll take the log of this product, which is raised to the 1/2 power. Notice my parentheses. And then I'm going to subtract, because it was a division problem, the log of a. Okay, so now we will move this power out in front. Notice the order that I'm doing stuff in. 1/2 will move in front of this log of BC. Okay, and once that power is moved, you don't have to do an extra parentheses. Once that power is moved, you could just leave it as the way I've written it here. And then we're going to do minus log of a. Whoops. And then the expanded form, again, this looks very similar to something that was like this, but also like this. So we got to be careful about parentheses. What I just boxed here would become log of b plus log of c. Then this 1/2 would multiply by all of that. So that was going to be a 1/2 that's distributed on both. I'm going to go ahead and distribute it out. And then for this last one, it's just going to be minus log of a. Notice it didn't distribute all the way to log of a. It was just for that term that it was glued together by multiplication right here. That's where it distributed on. Okay. And then the last one we have is log of, let's break up the division first. So we have 1000 a squared. And then it's going to be subtracting log of c. And then now I'm going to see that there's multiplication that happens right there. So let me break those up. So I have log of 1000 plus log of a squared, and then minus this log of c that was still remaining. And then now I can move this power out in front. I'm combining all these laws of logs so that I get log of 10,000. Okay, so log of 10,000, or sorry, 1,000 is going to be adding with 2 log of a, and then which is going to be subtracting c, or subtracting log of c. And that's what you would get as your final answer for that one. All right, so now let's go ahead and move on to our last slide. Okay, so our last page. Expressed as a single logarithm. So now instead of expanding, we're going to combine. So the other one was expanding. Now we're going to combine. Okay, so we're going to move the power first. So we have log of b squared plus log of c cubed, because that went out in front for that one. Again, remember, these were the original arguments that we ended up moving that power to. So it's like we could put it here and here, that the c moved, or sorry, the 2 and 3 moved as the powers. Okay? So then finally, we're going to combine, because this was addition, to multiplying these arguments. So it's the same thing, only backwards. Okay? So we're going to have 1 log. That's very important. When you combine, you have 1. When you expand, you have more than 1 possibly. And it's going to be the multiplication between b squared and c cubed, which you can leave just like that. Okay? Again, if you did not put parentheses here, that's okay. It's equivalent, because I said anything that follows a log that's glued together with multiplication is considered to be the full argument. Okay? All right. So the next one, we're going to go ahead and move 2 to the power. So it'll be log of a squared minus log of b to the 4th. Again, we're trying to combine. And then now this subtraction says we're going to be dividing. So log of a squared divided by b to the 4th. Whoops. And this is our full argument for our answer. All right, so now we're almost done. Let's move this to the power of a. So we have log of a to the 1/2, which is square root of a. We have plus log of c squared. Okay, so I took care of the powers first. Now the next part is to look at, they are adding. And because they are adding, these 2 arguments are not going to be glued together with multiplication. So we'll have c squared times the square root of a. We could write it like this too, because order doesn't matter with multiplication. And we would get that. Okay? If you write log of square root of ac squared, please make sure that you do not show that this is underneath the square root. You can write it like this, but make sure that we know that they're multiplying together and they're not underneath the same square root. All right, so now this 1/2. This 1/2 is going to be distributed on both of them. Big important misconception that some people struggle with. So distributing on both of them will have 1/2 is basically not foiled, but distributed on both to look like this. And then from here, we will raise these coefficients to become powers so that we have log of b to the 1/2. Okay, which you can write b to the 1/2. I just like to write, when I know it's 1/2, just the square root. This would be log of the square root of c. And then because they are subtracting, yes, we will end up dividing these when we combine them to one logarithmic function. Okay, so you could see it like this right here, or from radical properties that we learned in previous units. When we know the square roots are like this, we could also combine them as being 1, which you would see like this. So either way, those are the same answers. All right, so now the next one. So all these are like the special cases, if you will, that a lot of people struggle with. The negative distributions, a lot of people struggle with those negatives, especially when you get to calculus, okay? So this is going to be minus 3 log of a, and then minus log of b. Again, this negative distributed across that parentheses, okay? So 2 log of c is up front. And then now from here, you can treat this as just looking at this 3 is going to be a power of a. So to be, here we go, log of c squared, I'm raising those to the powers, minus log of a cubed, minus log of b. Okay, so you can see it in this respect that when I combine these two together, I'm going to be dividing. So I have c squared divided by a cubed. And then technically I still have this log of b. And guys, when I'm going to divide these now, c squared over a cubed divided by b, because now I'm going to bring this into the mix with division because it's subtracting here, is the same as, again, dividing by b is the same as just multiplying by 1 over b. So all I'm going to do is I'm going to bring that in to my denominator so it ends up multiplying with this a cubed so that I get a cubed times b in the denominator and c squared in the numerator. And then I would have log. This would be my final thing. Now there's many ways that you can do this. The way that I just did it is definitely one of them. But some people might try to combine the first, these in parentheses, they will try to combine them with multiplication first. Let me show you what that looks like. This a and b, okay? So this is log of a cubed plus log of b. And if I combine a cubed and b together with multiplication, then I would have, let me show you over here on the side, I would have a cubed times b, because it was addition here, and it was subtracted from this 2 log of c. So 2 log of c minus that. Well, we know 2 log of c is the same as log of c squared. We did that before. So log of c squared. And now log of c squared divided by all of this shows why we're going to have all of that in the denominator. So parentheses and the grouping of it, it's definitely important as far as how you do it, where that negative distributes, but nonetheless, you still see you're going to get the same answer. Okay. The thing that I kind of wanted to show you from that is that if you did it my way, as far as distributing it first, notice how we had, go ahead and do that. Notice how we had 2 subtractions. That means we're going to have c squared and on the denominator, a cubed. And again on the denominator, because there was another subtraction, b. And then if there was an addition, then we know anything that is adding, we would put in the numerator. Anything that was subtracting, we would put in the denominator. That's why I wanted to kind of show you here, okay? There are a lot of different case scenarios, but please please make sure that you get the practice. So log of c squared over a cubed times b is the answer for this one. All right, so now let's go to our last ones. We're almost done. And I know I keep saying that, but we really are almost done. This is it right here. All right, so we are adding and subtracting. This is why I wanted to show you this, guys. Log base b cubed, log of a, and log of c squared. I took care of those coefficients first by making them powers of the arguments, okay? These two were adding, this was subtracting. Now I said anything that's adding to a previous term, you're going to multiply them. This will multiply and they will end up in the numerator. So we'll have ab cubed in the numerator. And anything subtracted is going to be in the denominator because it is division. Okay, so whenever you combine them together, it will go to c squared in the denominator. Then you have log of this, and that would be your final answer. So that's why I showed you from the previous example, number 15, of how you can look at those plus and minuses and quickly identify where they're going to go, where do they belong, and so on and so forth. All right, so now let's move to 17, and we're going to use the properties to evaluate the expressions. Okay, here we go. Log base 5 of 1 to the 1/2. Well, 1 to the 1/2 is the same as square root of 1. Okay, we're going to subtract log base 5 of 5 squared, which is the same as 25. Okay, and now if I wanted to solve this, well, the square root of 1 is just 1. I could just write 1 there. And because this is subtraction, I can combine with division, the laws of logs that we learned. So 1 log of 1 over 25. And now, all of this is equal to something, and the reverse Hart method tells me 5 to the power of something is 1 over 25. We've done problems like this already. 25 in the denominator is the same as 5 squared. If I rewrite it, so I have a base to a power is equal to a base to a power, so that my bases are the same and now negligible, then I could say x is -2. So if x is -2, then all of this, which came from here, is -2. Okay? Number 18, express 2 plus log of x is equivalent to what? So we know it's not this one, because that one would be log of x squared. Okay, and that's not what we have. So let's look a little bit more. All of these are like 10, if you will. They're bases. And we're going to say that it's equal to something. So 10 to the power of something is 2x. Well, 10 to the power of something is 2x does not really show this as far as being that something. Okay, so let me show you what I'm talking about. This really doesn't have that same property that's going on, because in this specific one, since we're adding 2, not multiplying, but adding 2, it's actually going to be this one right here. And let me show you why. Okay, first of all, if I rewrote this, I have a product between 100 and x. So it's like a product there would be addition between 2 separate ones. So log of x base 10. Okay, again, from the laws of logs that we learned, 1 log that had a product in the argument will have 2 logs that have a sum between both of them. Okay, and now look here. We have log, oh, I copied 1,000 instead of 100. My mistake on that. We have log base 10 of 100. And this right here, if I were to set it off to the side and say, what's log base 10 of 100? Well, we know it's equal to something. And that 10 to the something rewrite would show that that something would be 2. So this is just 2 plus log base 10 of x, which is what we got here. Okay? So what if the base is something we can't work with? We're going to use the change of base property. And that's where you would go to rewriting and getting practice with that change of base that was in that other video. So that's all we have. Guys, rewind Ask questions if you need to. Please reach out on Palette. And don't forget to make sure that you are using those live tutorials.